In August of 2025, a Chinese electric car went around the Nürburgring in Germany faster than any electric car in history. 6 minutes, 59 seconds, and a fraction. It beat cars from Porsche, from Rimac, from companies that have been building performance machines for 100 years. A few weeks later, the same car lined up on a closed test track in Germany and hit 496 kilometers per hour. That is over 308 miles per hour. It became the fastest production car in the world, electric or otherwise, beating a list of names that used to own that record without any real competition. The car is called the Yangwang U9. It is built by BYD, a company that most people outside of China had never heard of 10 years ago, and that a lot of people still think of as a battery manufacturer that also happens to sell cheap electric hatchbacks. And here is the part that made the executives in Maranello and Stuttgart sit up straight in their chairs. It was not the speed. Speed can be bought. It was everything underneath the speed. The battery, the motors, the suspension, the software, even the tires. Almost all of it was made in China, by Chinese companies, using Chinese engineering. If you are enjoying videos like this, hit the like button, because these take a serious amount of work to put together, and subscribe so you do not miss the next one. This is the story of how a battery company from Shenzhen decided to build a hypercar, and what that decision says about where the global car industry is actually heading. Because the U9 is not really about one car, it is a message. And messages like this are rarely aimed at the people who receive them first. This one was aimed at boardrooms, at suppliers, and at buyers who had never once considered a Chinese badge. At least not seriously. To understand the message, you first have to understand how absurd the whole idea was in the first place. Go back to 1995. A 30-year-old chemist named Wang Chuanfu quits his government research job in Beijing, borrows money from a relative, and starts a small company in Shenzhen making rechargeable batteries. Not car batteries. The little batteries that go into mobile phones and cordless drills. At the time, Japanese companies dominated that market completely. They had automated production lines that cost tens of millions of dollars. Wang could not afford anything close to that. So he did something that a lot of people thought was ridiculous. He broke the production process down into dozens of small manual steps and hired hundreds of workers to do them by hand, with simple jigs and fixtures he designed himself. It was slow, it was labor-intensive, but it worked, and it was cheap. Within a few years, his company was supplying batteries to Motorola and Nokia. That is where the name comes from, BYD. Then in 2003, Wang did something that made his investors furious. He bought a struggling state-owned car company. His shareholders thought he had lost his mind. The stock dropped. Analysts asked why a successful battery maker would jump into the most brutal, capital-hungry industry on earth, in a country where the domestic car brands were considered a joke. His answer was simple. He was not buying a car company. He was buying a customer for his batteries. He believed that one day cars would run on electricity, and when that day came, whoever controlled the battery would control the car. That was more than 20 years ago. Almost nobody believed him. For the first decade, BYD made cars that were, honestly, not very good. They copied designs from Toyota. The interiors were cheap. The quality was inconsistent. Chinese consumers who could afford something better bought German or Japanese. BYD survived by selling to taxi fleets and price-sensitive buyers, and by keeping the battery business running in the background. But something was happening underneath. While the rest of the industry was outsourcing everything, BYD was doing the opposite. They started making their own semiconductors, their own motors, their own power electronics, their own seats, their own air conditioning compressors, their own lights. At one point, BYD was manufacturing something like 3/4 of the parts in its own cars in-house. In the car industry, this is considered old-fashioned and inefficient. Henry Ford did it 100 years ago, and everyone eventually decided it was a bad idea. You are supposed to focus on design and assembly and let specialized suppliers handle the components. BYD ignored all of that, And for years, it looked like a mistake. Then, the world changed. When electric vehicles finally took off, the bottleneck was not design, it was not marketing, it was batteries, chips, and power electronics. The exact things every other car maker had to go begging for. Companies that had spent decades outsourcing suddenly found themselves standing in line, paying whatever price their suppliers demanded, waiting months for parts. BYD did not have to stand in line, they already owned the factory. In 2020, they released something called the Blade battery. Instead of packing cells into modules and then packing modules into a pack, they made long, flat cells that slot directly into the structure of the car, like blades in a rack. It used lithium iron phosphate chemistry, which is cheaper, more stable, and lasts longer than the nickel-based chemistry most premium electric cars used. It was also considered less energy dense, which was supposed to be a fatal weakness. BYD solved that with packaging. By eliminating the modules, they fit more cells into the same space. The pack became part of the car's floor and added rigidity to the chassis. They also ran a demonstration where they drove a steel nail straight through a blade cell to show it would not catch fire. That video went everywhere in China. By 2022, BYD stopped building combustion-only cars entirely. By 2023, they had passed Tesla in total electrified vehicle sales. By 2024, they were selling over 4 million vehicles a year and had become one of the largest car makers on the planet. And that is when they had a problem that has nothing to do with engineering. BYD had become enormous. But it had also become known for one specific thing: value. Affordable cars, sensible cars. The kind of car you buy because it makes financial sense. That reputation is worth billions. It is also a ceiling. If you want to sell a car for $80,000, or $200,000, or $500,000, nobody cares that your engineering is efficient. They care whether your badge makes them feel something. And BYD's badge made people feel like they had made a smart decision. Which is not the same thing at all. Every large car maker eventually runs into this. Toyota built Lexus. Nissan built Infiniti. Volkswagen bought its way up market with Audi, Bentley, Lamborghini, and Porsche. Hyundai spent years and enormous sums building Genesis from nothing, and then spent even more convincing anyone to care. So, in 2023, BYD launched a new brand. They called it Yangwang, which roughly translates to looking up, or gazing upward at something above you. The first Yangwang product was not the U9, it was the U8, a large boxy SUV. And instead of trying to out-luxury the Germans on leather and wood, BYD did something stranger. They gave it 4 separate electric motors, one at each wheel, and then built software that could do things no conventional vehicle can do. The U8 can spin in place like a tank, turning the wheels on one side forward and the other side backward. It can float. BYD drove one into a lake, and it sat there bobbing on the surface, sealed tight, using its wheels to slowly paddle to shore. They also showed it driving in a straight line after a front tire completely blew out, because the remaining 3 motors just quietly compensated. Those demonstrations went viral, and they made a specific point. This was not luxury as an idea. This was capability that came directly from a technical architecture that traditional car makers cannot easily copy, because it depends on controlling every motor, every millisecond, with software you wrote yourself. The U8 proved the concept, but an SUV that floats is a novelty. To be taken seriously by the people who take cars seriously, you need something else. You need a hypercar. And that is a very different kind of test, because a hypercar is not a car. It is a claim. It is a company standing up in front of the entire industry and saying, "We can do this too, and here is the proof. Go measure it yourself." And if the claim is wrong, everyone finds out immediately. The Yangwang U9 arrived in early 2024 with a price of around 1.68 million yuan, roughly $230,000, depending on the exchange rate, which sounds like an enormous amount of money, and it is, but it is also less than a Ferrari, less than a McLaren, and dramatically less than the small handful of electric hypercars that had come before it. The basic specification reads like something out of a video game. 4 electric motors, 1 per wheel, producing a combined output in the region of 1,300 horsepower in the standard car, with later versions pushing far beyond that. 0 to 100 kilometers per hour in about 2.36 seconds. Not because of some launch control trick, but because 4 wheels, driven independently, can put down power in a way 2 driven wheels physically cannot. But the horsepower is the least interesting number. The interesting part is what BYD did with the suspension. Every car you have ever been in has a suspension that reacts. A wheel hits a bump, a spring compresses, a damper controls how fast it moves. The system is always responding to something that already happened. Even the very best adaptive dampers, the ones in expensive German sedans, are simply adjusting how stiff they are, dozens of times a second, based on what the sensors just felt. BYD built something they call DSUS X, and it does not react, it acts. Each wheel has its own hydraulic and electric actuator that can push down or pull up with real force, independently, extremely fast, under direct software control. The car has cameras and sensors reading the road surface ahead, so instead of waiting for the wheel to hit the pothole, the system already knows the pothole is coming and pushes that wheel down into it and back up out of it before the body ever notices. And when engineers build a system that powerful, they inevitably start playing with it. BYD released a video of a U9 with 1 wheel completely removed, driving on 3 wheels, the empty corner held up in the air by the suspension itself. Then they did it with 2 wheels removed, diagonally opposite, the car balancing and driving on the remaining 2 like something out of an animation. Then they made the car jump, not roll over a ramp, actually launch itself off the ground by slamming all 4 actuators down at once. Then they programmed a fleet of them to bounce and sway in unison to music, which is either the most impressive or the most ridiculous thing ever done with a $200,000 car, depending on your temperament. The stunts got the attention. But underneath the theater is the actual point. A car that can control the load on each individual wheel in real time with real force can keep all 4 tires pressed into the road through a corner in a way that steel springs never will. It can resist body roll without making the ride harsh. It can shift grip from one corner to another mid-corner. That is not a party trick. That is lap time. And lap time is the currency this whole world runs on. Which brings us to Germany. The Nürburgring Nordschleife is a 20-kilometer stretch of old racing circuit in the Eifel Mountains, and for reasons that are mostly historical and slightly irrational, it has become the place where performance cars go to be judged. It is narrow, it is bumpy, it has enormous elevation changes, blind crests, and almost no runoff. It punishes cars that are fast in a straight line and terrible everywhere else. It punishes heavy cars especially. Electric hypercars have always struggled there, not because they lack power, but because they carry hundreds of kilograms of battery, and because sustained hard driving heats that battery until the car quietly reduces its own output to protect itself. Plenty of very fast electric cars are only very fast for about 90 seconds. In August of 2025, a track-focused version of the U9 went around the Nordschleife in 6 minutes, 59.157 seconds. That made it the fastest electric car ever recorded on the circuit, and put it in the conversation with the fastest cars of any kind. Not the fastest ever, but comfortably inside the small group of machines that most people have never seen in person. And then, in September, on a high-speed proving ground, the same platform recorded 496.22 kilometers per hour. That is a number that used to belong exclusively to Bugatti and to a handful of tiny specialist manufacturers building a dozen cars a year for collectors. So how did they do it? The extreme version of the U9 does not use a conventional 800-volt system, which is what the most advanced electric performance cars had settled on. It runs a 1200-volt architecture. Here is why that matters, without the engineering jargon. Electrical power is voltage multiplied by current. If you want to move an enormous amount of power, you can either push more current or raise the voltage. Pushing more current means thicker cables, more heat, more waste, and heavier components. Raising the voltage means you can move the same power through thinner wires with less heat. Heat is the real enemy in an electric performance car. Every bit of energy that turns into heat instead of motion is energy that did not accelerate you, and it is also energy that is slowly cooking your battery until the software decides to protect itself and cut your power. Going to 1200 volts is a way of attacking that problem at the root. But you cannot just decide to run 1200 volts. Every component has to be built for it. The battery cells, the inverters, the motors, the connectors, the semiconductors that switch the current thousands of times per second. Most car makers would have to convince half a dozen suppliers to develop entirely new parts, negotiate volumes, wait years. BYD makes its own batteries, its own motors, its own power electronics, its own silicon carbide semiconductors. The entire chain, in-house. That is the 20-year-old decision that everyone laughed at in 2003, paying off in the most visible way possible. There is one more detail from that top speed run that got far less coverage than it deserved, and honestly, it might be the single most significant thing about the entire project: the tires. At nearly 500 kilometers per hour, a tire is under stress that is difficult to describe. The rubber is spinning so fast that centrifugal force alone is trying to tear it apart from the inside. The temperature climbs. A failure at that speed is not an incident, it is a catastrophe. There are only a small number of tire companies on Earth capable of building something that survives it, and they have historically been European or Japanese. Michelin, Pirelli, Bridgestone. The U9's record run used tires developed by a Chinese manufacturer. For decades, Chinese tires were the definition of a budget product. Fine for a delivery van, absolutely not something anyone would put on a performance car. That was a genuine technology gap, not a branding problem. That gap just closed, publicly, at 308 miles per hour. Think about what that actually requires on the ground. A tire like that is not designed on a computer and shipped out the door. It takes test rigs that spin a wheel at 500 kilometers per hour for hours at a time, inside a sealed chamber, because if the tire lets go, the pieces will go straight through a wall. It takes compound chemistry, steel belt construction, and a testing program that costs a fortune and produces nothing you can actually sell. Somebody in China decided to fund all of that for a market of maybe a few hundred cars a year, purely to prove it could be done. That is the detail that should worry people more than the lap time. Records get broken. Testing infrastructure does not go away. And that pattern is really the whole story. Not one company doing something impressive, but an entire industrial ecosystem quietly moving up the ladder at the same time. Batteries, motors, semiconductors, software, suspension, and now tires. So why does any of this make Ferrari nervous? Ferrari sells around 13,000 cars a year. BYD sells that many in a bad afternoon. The two companies are not competing for the same customer in any direct sense, and anyone who tells you the U9 is going to hurt Ferrari's sales next quarter is not being serious. The threat is slower and much more uncomfortable than that. For 100 years, the premium car business has run on a story. The story says that certain countries and certain companies possess a kind of engineering knowledge that cannot be bought or copied, that there is something in Modena, in Stuttgart, in Woking, that took generations to accumulate. You are not just buying a fast car, you are buying access to that history, and for a very long time, the story was mostly true. Building a great combustion engine really is extraordinarily hard. Getting a chassis to feel right really does take decades of accumulated intuition. Money alone genuinely was not enough. Plenty of wealthy people in wealthy countries tried to buy their way into that world and produced expensive disappointments. Electrification does not erase all of that, but it moves the goalposts, and it moves them onto ground where the traditional advantage is much smaller. If the hardest part of the car is no longer a naturally aspirated V12, but a battery pack, 4 motors, and about 10 million lines of software, then the question becomes uncomfortable. Who is actually best at those things? And the honest answer is that the companies with the deepest experience in batteries, motors, and power electronics are mostly in Asia. They have been building that expertise for 20 years, while European car makers were perfecting turbochargers and dual-clutch gearboxes and telling themselves electric cars were a compliance exercise. This is what the U9 is really saying. It is not saying we are better than Ferrari. It is saying the thing you are best at is becoming less important, and the thing we are best at is becoming the whole game. And there is a second message underneath that one, aimed at a completely different audience. Halo cars have always had a job to do inside the company that builds them, and it is not to make money. Almost none of them make money. Their job is to change what people believe about the badge. When Lexus built the LFA supercar, it lost money on every single one. But it changed the conversation about whether a Japanese luxury brand could build something with soul. When Hyundai went rallying and then built the N division, it was not chasing profit. It was buying the right to be taken seriously. BYD is playing exactly the same game, and it is playing it in front of two audiences at once. The first is Chinese consumers. For a long time, buying a domestic brand in China meant accepting a compromise. The desirable cars were German, Japanese, American. That perception is collapsing, and cars like the U9 accelerate the collapse. A young buyer in Shanghai, looking at a BYD sedan, is now looking at a badge that also builds the fastest production car in the world. That changes what the badge feels like. The second audience is everyone else. BYD is expanding aggressively into Europe, Southeast Asia, Latin America, and Australia. It is building factories in Hungary, Turkey, Brazil, and Thailand. In every one of those markets, it faces the same instinct. Chinese car, therefore cheap, therefore probably not good. A Nürburgring record does not remove that instinct on its own, but it makes it much harder to say out loud with a straight face. Now, the skeptics have real arguments, and it is worth taking them seriously rather than pretending they do not exist. The first is weight. The U9 is heavy. Physics does not care how clever your suspension software is. A car with a large battery carries mass that a lightweight combustion car does not, and mass affects braking, direction changes, tire wear, and the fundamental feeling of agility that enthusiasts care about most. Active suspension can hide a great deal of it. It cannot delete it. The second is the difference between a record and a car. The versions that set those numbers were extreme, low-volume machines prepared specifically for those runs. That is completely normal. Bugatti did the same thing. Koenigsegg does the same thing. But it does mean the car in the record video is not the car in the showroom, and anyone treating those as identical is being sold something. The third is durability. Ferrari and Porsche have decades of data on what their cars do after 10 years and 100,000 kilometers in the hands of owners who are not gentle. Nobody has that data on the U9 because it has not existed long enough. High voltage systems, active hydraulic suspension, 4 independent motors, that is a lot of complexity. And complexity ages. The fourth is the emotional argument, and it is the one that makes engineers roll their eyes and customers nod. A large part of what people buy at this price is noise, vibration, drama, and the sense that a machine is barely tolerating them. An electric hypercar is astonishingly fast and comparatively silent. Some people find that thrilling. Others find it hollow, like winning an argument with a calculator. That is not a technical problem BYD can solve with better software. It is a matter of taste, and taste takes a generation to shift. The fifth is simply distribution. Selling a $200,000 car is not like selling a $20,000 one. It requires dealerships that feel a certain way, service networks that can handle rare parts, and a relationship with customers who expect to be treated as members of a club rather than buyers of a product. Ferrari has spent 70 years building that. It cannot be assembled in 18 months. And there is a sixth argument, which is the least glamorous and possibly the most important. Regulation. Getting a car like this certified for sale in Europe or the United States is a slow, expensive, deeply unromantic process involving crash tests, paperwork that somehow still applies to electric cars in odd ways, lighting standards, and safety systems that differ from market to market. BYD has been grinding through that process for its ordinary models. A hypercar is a completely different set of hurdles, and for a car built in tiny numbers, the cost of clearing them can easily exceed the profit on the entire production run, which is one reason you should not expect to see many of these outside China anytime soon. So no, the U9 is not going to empty Ferrari's order books. But here is the thing about the argument that Chinese cars are just cheap, or just copies, or just subsidized. It is exactly the same argument that was made about Japanese cars in the 1970s and about Korean cars in the 1990s. In 1970, Toyota was a joke in America. Small, tinny, disposable. 15 years later, Toyota was setting the global standard for reliability and manufacturing, and Detroit was in crisis. In 1990, Hyundai was famous for cars that fell apart. 20 years later, Hyundai and Kia were winning design awards and taking market share from everyone. The pattern is always the same. Enter at the bottom on price. Use the volume to fund engineering. Climb slowly. Get dismissed at every stage by incumbents who keep pointing at last year's product. And then one day the incumbents look up and the gap is gone. And at every stage, the dismissal sounded completely reasonable. The cars really were worse. The criticism really was accurate. That is what makes the pattern so hard to see while you are standing inside it. You are not wrong about the product in front of you. You are wrong about the direction of travel. What is genuinely different this time is speed and scale. Japan's climb took roughly 30 years. Korea's took about 25. China's electric vehicle industry has gone from irrelevant to setting world records in something closer to a decade, and it has done it while also controlling the upstream supply chain in a way neither Japan nor Korea ever did. Because that is the part that should really keep executives awake. It is not the lap time. It is the fact that a very large share of the world's battery cells, cathode material, anode material, battery-grade lithium processing, and rare earth magnets flow through Chinese companies. A European carmaker building an electric hypercar is very likely buying critical components from the same supply chain that produced the car that just beat it. You can compete with a rival. It is much harder to compete with your own supplier. So what happens next? The traditional players are not standing still, and it would be foolish to write them off. Ferrari has launched its own electric model and has been extremely careful about how it does it, because it understands better than anyone that its brand is its actual product. Porsche has been building electrified performance cars for years, and knows more about how enthusiasts think than almost any company alive. These are not sleeping giants. They are awake and they are worried, which is exactly the condition in which they historically do their best work. But the terms of the competition have changed permanently. It is no longer about who can build the best engine. It is about who controls batteries, power electronics, semiconductors, thermal management, and software, and who can iterate fastest. On that specific list, the balance of power has shifted, and it has shifted a long way. The Yangwang U9 will never be a common sight. Most people will never see one, let alone drive one. In pure commercial terms, it is close to irrelevant. A rounding error against 4 million ordinary cars. But that was never the point. The point was to walk into the most exclusive room in the automotive world, a room that has had the same members for 70 years, and prove with a stopwatch that the door is not locked anymore. And the U9 did that, in Germany, on German roads, with a stopwatch that nobody in Stuttgart or Maranello was holding. What happens over the next decade will not be decided by hypercars. It will be decided by millions of ordinary vehicles, by factories in Hungary and Brazil and Thailand, by tariffs and trade rules and politics that have nothing to do with lap times. Those forces are messy and slow, and they will shape the outcome far more than any record run. But every so often, an industry has a moment where a belief that everyone quietly held simply stops being true, where the thing that was supposed to be impossible turns out to have been done and documented and timed. A battery company from Shenzhen, founded by a chemist who could not afford a robot, just built the fastest production car on Earth. That should not have been possible. And the fact that it was tells you almost everything you need to know about where this is all going. If you found this interesting, drop a like and subscribe. Every week we break down the technologies, factories, and industrial shifts that are quietly reshaping the world. The stuff that rarely makes the headlines but changes everything underneath them. Turn on notifications so you catch the next one, and there are related videos on screen right now if you want to keep going. So here is my question for you. If a car is faster than a Ferrari, more advanced than a Porsche, and costs less than both, but wears a badge nobody grew up dreaming about, would you actually buy it? Or does the badge still matter more than the numbers? Let me know in the comments.